Hello students, in today's lecture we'll study the basics of beta function. The beta function of a number of two numbers, say L and M, is given as definite integral from the lower limit 0 to the upper limit L, and integrand here x raised to L minus 1 into 1 minus x raised to m minus 1 dx. Now in this integral, this variable is x. One can replace this x by y, or it can be replaced by z or p or t, because in the definite integral, what is the symbol for the variable is immaterial. Now suppose you have the integral which is to be evaluated, and that integral is of this form. Of this form means some variable is there raised to some power, and one minus variable is there raised to another power. You can write it as a beta function, and in fact the beta function can be written in terms of the gamma function, and the values of the gamma function can be found using the properties of the gamma function, and hence the value of the given integral can be evaluated. Also, some integrals can be converted into this form, that is of the beta function, and hence its value can be found. The beta function has only one property, that beta of L comma m is same as beta of m comma L. So that means if you interchange those two numbers L and m, the value of the beta remains. Values of the beta function can be found by finding the values of gamma function, and this beta function is related with the gamma function with the equation beta of L comma m equal to gamma of L into gamma of m divided by gamma of L plus m. And in fact, this property is very useful to find the value of beta, because the value of the gamma can be known from the properties of the gamma function, and once you get the value of the beta, one can evaluate the given integral. Let us take the example of integral which can be transformed into the beta function, and how to find the value of that beta function. So consider this integral 0 to 1 x raised to 4 into 1 minus root of x raised to 5 dx. Now this integrand is not the same form as that of the integrand in the beta function. So we try to transform here this integral to that of the beta function. So let us do the substitution. Let us say that root of x equal to t. Therefore, if you square on both the sides, you will get x equal to t square, and when you differentiate, you will get dx by dt equal to 2t, that is dx equal to 2t dt. Now you substitute this in above integral. So what you get here is that x equal to t square, so x raised to 4 is t raised to 8, and the root of x, that is x raised to half, is equal to t raised to 2 by 2, that is t. So therefore, after substitution, what you get is integral 0 to 1 t raised to 8 into 1 minus t raised to 5 2t dt. We have substituted here dx is equal to 2t dt. Then 2 comes out, and this t raised to 8 into t, that is t raised to 8 plus 1, that is 9. So therefore, this turns out to be 2 into integral from 0 to 1 t raised to 9 into 1 minus t raised to 5 dt. Next, we have to write this integral in form of that of the beta function, which is integral 0 to 1 t raised to L minus 1 into 1 minus t raised to m minus 1. So we write here that 9 as 10 minus 1 and 5 as 6 minus 1. Now this integral in the second step is same as that of the beta 10 comma 6. The beta 10 comma 6 can be written in terms of the gamma function by using the relation that beta 10 comma 6 equal to gamma of 10 into gamma of 6 divided by gamma of 10 plus 6. Now, in order to use the property of the gamma function that gamma of n plus 1 equal to n factorial, we write this gamma of 10 as gamma of 9 plus 1, gamma of 6 as gamma of 5 plus 1 and gamma of 16 is gamma of 15 plus 1. And the gamma of 9 plus 1 is nothing but 9 factorial, gamma of 5 plus 1 is 5 factorial and gamma of 15 plus 1 is 15 factorial. Then 9 factorial can be written as 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, and 5 factorial can be written as 5 into 4 into 3 into 2 into 1, and the 15 factorial can be written as 15 into 14 into 13 up to into 1. And then you have to calculate this value, and that is the final answer.